Students, let us learn the sixth question. 5-meter long ladder is placed leaning towards a vertical wall such that it reaches the wall at a point 4-meter high. If the foot of the ladder is moved 1.6 meter towards the wall, then find the distance by which the top of the ladder would slide upwards on the wall. Okay, so what is the length of the ladder? 5 meter. It is leaning on the vertical wall. Okay, we know the wall and the ground. This is the ground. This is the wall. Wall and the ground are perpendicular to each other. Okay, so here you can mark 90 degree. Next, the length of the ladder is 5 meter. The ladder we will lean like this way to the wall. Okay, actually this is the first position, AC of the ladder. AC is the ladder. Okay, it is the first position. The length of the ladder is 5 meter. Then the same ladder moving towards the wall. Okay, here this A position moved to D position. So this AD length is 1.6 meter. How much moved towards 1.6 meter? Okay, so 1.6 meter moved towards the wall. So AD length is 1.6 meter. First given, the ladder lean to the wall at height 4 meter. So BC length is 4 meter. Okay, now AC length 5 meter, BC length 4 meter. Also, the ladder is moving towards the wall 1.6 meter. So we will get AD. DE is the second position. So AD is 1.6 meter. Okay, anyway, since the same ladder is moving, there is no change in the length. So DE is also 5 meter. Am I correct? Same ladder only we moved towards, so there is no change. D equal to 5 meter. Okay, now we need to find out the distance by which the top of the ladder would slide upwards on the wall. You have to find how much distance to move upward. CE distance. Okay, so first of all you find this AB distance using this right triangle ABC. In that you know AC and BC, so you can find out the third side AB. Okay, using the Pythagoras theorem. Then from this AB, if you subtract AD, you can find out DB. Am I correct? So you know this DB length, already we know the DE length. You can find out this third side BE. Okay, BE. From that you subtract 4 meter and you can find out CE. That is the procedure. We can do one by one, so you will understand more. Are all clear? So we can start the solution. This diagram is the solution part. Now first we can write the explanation about the diagram. Let AC and DE be the ladder of length 5 meter. Okay, then BCE be the wall leaning the ladder. Okay, therefore BC is equal to 4 meter and AD is equal to 1.6 meter. Okay, so we written the three given measures. Now we can find out this AB length. Since ground and wall are perpendicular to each other, ABC, triangle ABC and triangle BDE are the right triangles. Okay, so we got the two right triangles. Now by Pythagoras theorem, in triangle ABC, AC square is equal to AB square plus BC square, which implies 5 square is equal to AB square plus 4 square, which implies AB square is equal to 5 square minus 4 square, that is 25 minus 16. What is 25 minus 16? It is 9, that is 3 square value. So you will get the distance AB is equal to 3 meter. Okay, which is equal to 9, that is equal to 3 square. Okay, so AB square is equal to 3 square. Therefore what is AB? Which is minus plus 3 or minus 3. Okay, but AB is a distance, so we can write 3. The unit is meter. Okay, so we get AB distance, then we can find out the BD distance from this using this AD. Okay, therefore, otherwise instead of AB we can write as AD plus DB from the diagram, which is equal to 3 meter. Okay, from diagram, which implies what is the value of AD? It is 1.6 plus DB is equal to 3 meter, which implies DB is equal to 3 minus 1.6 meter. 3 minus 1.5 means 1.5. 3 minus 1.6 is 1.4. Okay, so DB is equal to 1.4 meter. Okay, so we get AB value. From AB we found the DB value. Next we can find the distance, how much it moved upwards. Okay, now by Pythagoras theorem, in triangle BDE, okay, there the hypotenuse is DE, so DE square is equal to DB square plus BE square. Okay, now what is DE value? DE value, it is the length of the ladder, same, so it is 5. 5 square is equal to DB value, we find out it is 1.4. So 1.4 the whole square. Since it is a decimal number, you put the bracket and write. Okay, otherwise you can misunderstand and take the square for only 4. Okay, so you put the bracket and write 1.4 square plus BE value we don't know, so that we can write as BE as BC plus CE. Okay, BC plus CE, the whole square. We divide the BE as BC. It is the first position, length of the first position of the ladder on the wall. Next it is moved up E, so we got extra length CE. So we written this BE as BC plus CE. Okay, now we can find the value. 5 square is 25. Which is equal to 1.4 the whole square. You can consider as 14 square. 14 square is 1.96, but 1.4 square means 1.4 into 1.4. So when you multiply 2 decimal part in the product, so in the square value also you need 2 decimal part, so you will get 1.96. plus what is the BC value? Already we know it is 4 plus CE, the whole square. Okay. Now we can find out the value for this. First of all, you take this 4 plus CE one side. So you will get 4 plus CE, the whole square is equal to 25 minus 1.96. What is the value of 25 minus 1.96? Do you know the subtraction? 25.00. Okay, here we have decimal part 2 digits, so you put 0.00 minus 1.96. Are you all clear? So when you subtract, you will get 0 minus 6, 4. Here 9 minus 9, 0. Then here 4. When you borrow this 1 from 5, you will get 4. 4 minus 1, 3, 2. Okay, so you will get 23.04. Okay, now what is the value of 4 plus C, the whole square? So you need to find the square value, square root using the long division method. Otherwise, you consider this value as a whole number 2304. You find out the prime factorization. Okay, anyway, you find the square root value for this, which is equal to 4 plus CE. Find the square value. It is square root of 23.04. Okay, but now both the side you take the square root. So this square value will cancel. You can write here, take square root on both the side. It is not compulsory. So the square will cancel. Next, here we have the square root. Okay, shall we do this? It is using 2. 1 2 is 2, 1 2 is 2, 5 2s are 10, 2 2s are 4. Okay, again, since it is a even number, using 2, 5 2s are 10, 7 2s are 14, 6 2s are 12. Again using 2, 2 2s are 4, 8 2s are 16, 8 2s are 16. Again using 2, 1 2 is 2, 4 2s are 8, 4 2s are 8. You know this 144 is the square value of 12. So we can write this as 12 into 12 is 144. So we will get the pairs. Okay, we will get the pairs. So what is the value? From this pair you will take 1 2. From this pair you will take 1 2. From this pair you will take 12. So 2 into 2 into 12. Okay, so 12 into 2, 24, 24 into 12, 24 into 2, 48. Okay, but this is a decimal number. In the decimal part you have 2 digits. So when you take the square root, you will get 1 digit in the decimal part. These all ideas we learn in the 8th standard itself. Have any doubt, you clarify from the 8th book. Okay, since we have 2 digits in the decimal part, so in the square root value you will get only 1 digit. Understood? So when you multiply 4.8 into 4.8, you will get this 23.04. That is the meaning. Okay, so we will get this value is 4.8. Okay, now we can find out the CE value. Therefore, CE is equal to 4.8 minus 4. Okay, that is equal to 0.8. What is the unit? Meter. Okay, so how much is the height increased? 0.8 meter. Okay, now you see the diagram. Here 1.6 meter it is moved towards the wall, but how much it is moved? Only 0.8 meter. Okay, so first we found the AB value using this right angled triangle. Okay, by the Pythagoras theorem. So we get this totally AB value. From that AB we subtracted this AD. So you got the DB value. So using this DB and this DE value, we found this total length BE. Are all clear? Total length BE. but in that BE we don't know the CE value, only we can apply this BC 4 meter, so we written as BC plus CE. Instead of BC we written 4 meter, so it is BC plus CE, then 4 meter plus CE. From that we found the CE value. Okay, that only we got, it is 0.8 meter. Are you all clear?